So this is the lesson 30's assignment. I went a little bit head over heels diving into it. It's taken me almost a week to do, but I really like the outcome. Actually, I liked it enough that I ordered an e-ink display to format this output onto that display to use permanently in our kitchen. So it's running now. I figured I'd show you the output and then walk you through the code. So it shows the current date and time, the current weather condition that it downloads from OpenMedio, overcast, just all the basics, the temperature, humidity, feels like temperature, winds with gusts, and the pressure. And then similarly, it gets today's forecast, the current day's forecast, and displays high temperature, low temperature, chance of precipitation, winds, sunrise, sunset. And then it gets the hourly forecasts, parses it for the next 6 hours, and displays that information here, including chance of precipitation, winds, feels like temperature, and then it gets the next day's forecast and displays it here. So tomorrow here it's supposed to rain with a high of 79, a low of 65, but the chance of precipitation really is only 24%. And then we live on the Chincoteague Channel Chincoteague Island, Virginia. We're actually only about less than a quarter mile down the channel from the Chincoteague Coast Guard Station, which is the closest tide reporting or tide point that I can get download from NOAA. So this is actually the tide information. It tells you if the tide is rising or falling, when the next tide will be, or next high or low tide, whichever comes first. So the next low tide will be at 10:32, and how low that will be, and then it shows you the next tide and how high or low that will be. And then I have deep water access for my boat, but there is a sandbar between me and the channel, so in order to get it in and out safely, the tide has to be actually at 0.8 feet or above. So what this does is it downloaded the 6-minute tide predictions from NOAA and calculates those windows as to when it's going to be above or below 0.8 feet. So you can see we currently are not in a boating window. The next boating window will open a little after midnight here and close at 7:24 a.m. But then the following one will open at 1:06 p.m. and close at 8:54 p.m. So, like I said, I really do like the output. I don't think I'm going to be able to fit this all on the e-ink display. I'm going to have to but the display does have buttons, so I'm figuring I could make multiple displays that we can toggle through. But anyway, let me show you the code for this now. I'll pull this down. It's a pretty long program. Like I said, it's taken me a better part of a week, so import the necessary items, connect to the network, declare all of our global variables that I would need. The first thing I did is get a function to set the local time at startup and then once per day right after midnight. So go to ntp time.setTime, get that, parse it into a list, offset, do some calculations to decide if we are currently 5 or 4 hours offset from the time that's reported at NTP time, and then set up a current date time list, and then write that current date time to the Pico, so the Pico's system time will be in line with Eastern time, which is where I live. And then at startup, it just will run this once before it gets to the while loop, so the time will be accurate. And then this is the function to fetch and extract tide data. The tide data is coming from NOAA. Formulated this API based on their instructions. Go out and request the download. Once we get downloaded, I parse it into a local dictionary, and then clear out what I downloaded. So there's just a lot of functions. So then that was get tide data, and again it calls it once, first time on startup. The next function is to calculating the next tides, where it takes that tide data, scrolls through it, and finds the first one, because it gives you the tide data for the entire day, even times that are past. So finds the first one that's in the future, sets that if it's rising or falling, and then goes through and finds where it crosses over that 0.8 feet. And actually, this actually just finds the next tide. This isn't the 8 foot logic, but it gets the next day and then builds the strings for the printout at the bottom. And there's a quick case if it's rising or if it's not rising, as to how it prints out and what's the next higher and low tide. And then we get the 6-minute tide data. This is for the boat windows. Same process. It comes from NOAA. It's the same process as getting the regular tide data. Download it, then parse it into a local dictionary, and then use that dictionary to calculate the windows. Here we talk about determine if we're currently in a boating window when it crosses the current time or not, and then goes from there and gets all of the times where it crosses that 0.8 foot mark, and saves those values for figuring out the printout later. And then this is the logic for figuring out what needs to be printed out, in the different strings that I'll use again at the bottom of the program to print out. And there's one for if we're currently in a window, where we say that we're currently in a window and it ends. And then there's the one you saw, we're currently not in a boating window, and then it tells you the next two windows. Here's to get the weather data. The weather data, I tried originally to get it from the National Weather Service, but that seemed to be a bit of a pain. They needed some header information. Their files were very big, and for some reason when I put the latitude and longitude Google Earth gave me, I was told it was a marine forecast. It was a point over the water. So I actually pivoted to the Open Medio. So here's the URL, and they actually had a nice handy website. You can select the variables you want, and it actually helped create the API. It needed to be changed a little bit for the Pico, but just really this character right here. And then again, it gets the data from them, parses it into local variables, and clears out what was downloaded. And then here's a function to create what you download from them, shows the wind direction in degrees. So in order to give the common north, northeast, northeast, east, northeast, there's this function. Whenever you need a degree, I just send it to degree, and it brings me back the appropriate designator as far as direction wise. And then here's the format weather data function. It does both. First, there's a key, the weather code for what the weather is now. I created this key that I could, or dictionary, I guess it is, that I could query to get, when I get a code, what the actual meaning of that code is. The current conditions just comes in a file. So I copied that into a local variable up above, and then create a string that prints out below that you saw. Today's forecast takes a little bit more parsing. You have to get the weather code key using the dictionary that I made up there, do the wind direction, get the wind direction. Sunrise and sunsets, you need to split the time so you can get the hour and the minutes to just display nicely, and then basically it's just building the string. I build the string, both today's forecast and tomorrow's forecast use this because they're pretty much identical. And then same for the hourly. It takes a little bit of work to get if it's AM or PM for the next 6 hours. Use the mod 12 to get the hour, and then if the hour turns out to be 0, you just make it 12. And then again, use a for loop to create a weather string for the 6 hours. This is the function to actually just get the local time. I only go out and set the local time once a day. Otherwise, you get it from the Pico's clock. So this is just updated actually every time through the while true loop, but it just takes the local time and parses it into a year, month, day, hour, minute, second, week, day, and the Julian day, I believe, is the last. And then I basically, in this function, I call a lot of the other functions based on the time. So if the at the mod 15 of the minutes, if it equals 0, so basically at 0 minutes, 15 minutes, 30 minutes, and 60 minutes, it would get the weather data, it would format the weather data, and then set that to be true. But I only wanted to get into that part if the weather updated was false, because there's 12 times a minute that it actually updates the data that's displayed, so I didn't want to do that 12 times. That, even though it's only 4 times an hour, I didn't want to do it 12 times, 4 times an hour. So it only does that once, and then once the mod 15 for the minute is not equal to 0, it sets that back to false, so that the next time it hits it's ready to go back through that loop. And then it asks, I had set a day up above, a day variable that it can compare, and basically when the days roll over is when it sets the local time and gets the new tide data. The tide data is forecast years in advance, I think, honestly, so I could download more at a time, but just to keep it simple and to not overload the memory, I just get it once a day and do the calculations. Then you actually get into the while true loop, which is pretty small. You go get the local time, convert it to AM PM, make the time string for the top of the display, and then basically do some logic to, if the tides that were being displayed are in the past, we would go get the tide data and calculate the next tides, or just calculate the next tides again, so we got only future tides. If for some reason there was some instant issue that the next tide data came back blank, there was some it would go and get new tide data, but that's only if there was some kind of error that occurred that kept things from happening as they should. And then finally at the bottom, it's just putting the output. This sets the screen to the top left each time through the loop, and then it's really just printing out the time and the different strings that I created up above. And then there's a 5-second delay before it goes back through the whole loop again. So I hope that makes sense. Like I said, I'm very happy with how it turned out. Let me get this set up to the right length again, and I'll restart the program so you can see how it actually starts up. So it's set out at the right height so that it fits good. So I'll stop it, and now I'll start it. So it connects to the internet, updates the tide data, updates the 6-minute tide data, updates the weather data, and then it does the calculations, and there's the display. 8:34, which is the correct current time, and then it shows the next 6 hours. So again, it was a lot of work, but I learned an awful lot doing it, and it was a lot of fun.